Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Foundation tier. Question number 2 is on the topic of energy. Let me make that a little bit. The student investigated the thermal conductivity of different metals. So you have different metal rods connected by the center, which is under the Bunsen burner, and the drawing pins are connected by wax. So as you heat from the center, heat should transfer outwards in all directions, and depending on how fast the heat is being transferred, the pin that is actually, as it gets to the end, it'll melt the wax and drop the pin. So the pin that actually drops first is the metal rod, is connected to a metal rod with the highest conductivity. Each rod was made from a different metal. The metal rods are joined at the center. The size of each metal rod was the same. This is the method used. Attach a drawing pin to the end of each metal using wax. Light the Bunsen burner. Start a stop clock. Record the time taken for the wax to melt and for the drawing pin to fall off each metal rod. Table 1 shows the results: copper, iron, nickel, and steel. So copper has the shortest time, steel has the biggest time. Complete figure 3. You should label the x-axis, plot the data. So you got copper, nickel, and iron. So let me write this by the graph. Copper, nickel, iron, steel. Copper is 10, iron is 22, steel is 18, 24. It's steel, sorry, nickel is 18. Right. So they've already labeled copper, iron, nickel, and steel. All we have to do is copy this for type of metal for our label. So type of metal. Now for the copper, I'm going to add shapes. Let's see if I can do that. So for the copper, it's 10. So there you go. That would be 10. Nickel is 22. Maybe I can copy this. So nickel is 22. So it doesn't go in the same order as in the table. So nickel is 18. And no, nickel is 22. Iron is 18. Iron is 18, a little bit bigger. There you go. And steel is 24. 25, that's be 24. There you go. Which type of metal in table 1 has the greatest thermal conductivity? That would be copper. Reason being, it had the shortest time, or it had the least time for the wax to melt. The thermal energy transferred to the nickel rod was 132 joules. The temperature change of the rod was 20 degrees. The mass of the rod is 0.015. Calculate the specific heat capacity. They have given you the equation, so all we have to do is substitute it energy transferred or thermal energy is 132 multiplied by the mass 0.015 multiplied by the temperature change. That would give me 440 joules per kilogram degree Celsius. Use the physics equation sheet to answer the following questions. Write the equation that links energy transferred, power, and time. Now, energy transferred E equals PT, or you can write power equals energy transferred divided by the time. You can write the word equation as well. At the end of the investigation, the Bunsen burner was turned off. As the nickel rod cooled to room temperature, the rod transferred 132 joules of energy to the room. The mean power was 0.33 watts. Calculate the time taken to transfer the energy. So power equals energy divided by the time. So time is equal to energy divided by the power. So 132 divided by 0.33 should give you 400 seconds. That brings us to the end of question number 2, and I will see you in question number 3.